Today we're going to be talking about meaning in logic. What is the best philosophical theory of what all those symbols mean? And I'm going to be focusing in on proof-theoretic semantics, what that is, where it comes from, what it can do, and perhaps some of the problems that the theory faces. Big thanks to the Consensus academic search engine for sponsoring this video. Okay, and we are going to jump straight in. There are basically two broad approaches to thinking about what logic means. The first is about truth and reference and connecting up symbols to the world. And the second is about proof, how we go about reasoning and proving using logic. So the truth-theoretic approach is kind of the standard. So when you learn logic, you do truth tables, you give interpretations for first-order logic, you connect up names with things and predicates with sets of things and so on, right? So that's connecting up symbols with the world and giving them truth values. That's the standard way of assigning meanings in logic. But there is this other approach called proof-theoretic semantics. And here we're thinking about the proofs as not just this thing we do in logic, but as the central feature of logic which gives all of the symbols their meaning. So proof-theoretic semantics, that is going to be our focus for this video. Let's talk a little bit about where it comes from. One of the main influences for proof-theoretic semantics in philosophy as a philosophical theory of meaning comes from Ludwig Wittgenstein in his philosophical investigations. So here, he's not talking so much about meaning in logic or maths, he's talking about the theory of what language means in general. And Wittgenstein's main idea here, his main slogan, is that meaning is use. To understand his ideas here, he gives us an example. Okay, so there's this guy, he goes into a shop and he's trying to buy 5 red apples. He's got this piece of paper and on it says 5 red apples. He hands it over to the shopkeeper. And let's suppose the shopkeeper has this chart that kind of correlates the word red with a colour sample, okay? So what he does is he looks at the word, he's got a chart that says, oh, it's this colour, there's an example, and then he looks at all his apples and he matches them up with a colour sample, and then he counts. There's 1, there's 2, there's 3, there's 4, there's 5, okay? So the shopper gets his 5 red apples, but the idea is the shopkeeper never really needed to understand anything about the meaning of those symbols beyond how to use them in a practical example. The number words correlate to our ability to count up to whatever number, and the colour words correlate to like patches of colour, samples, paradigms. There was nothing kind of spooky going on there, no talk about truth or reference or anything like that. Wittgenstein says no such thing was in question here, only how the word 5 is used. And his overall conclusion drawn from examples like this is, for a large class of cases, though not for all, in which we employ the word meaning, it can be defined thus. The meaning of a word is its use in the language. So this is where we get this famous slogan from Wittgenstein, meaning is use. Okay, now this applies to language in general, according to Wittgenstein. And when we take those ideas, that general theory of meaning, and apply it specifically to logic or maths, we think, well, what is the use of logical or mathematical language? Well, it's to prove stuff, okay? So this is where we get the specific idea that within logic, the meaning of those terms is given by its use in proof, or just by the proofs, okay? This is where we get the idea that it's the proofs that give the meaning of logical symbols. So here's a question for you. If you're coming across a term like proof-theoretic semantics for the first time and you want to get some reliable information about it, how do you do that? I've been using the Consensus academic search engine. They've been kind enough to sponsor this video. Consensus is an AI-powered academic search engine that pulls results from peer-reviewed papers, so not just from blog posts or random websites. So if we go to consensus.app and we put in what is proof-theoretic semantics, proof-theoretic semantics is an approach to semantics that emphasizes the role of proofs rather than truth conditions in determining the meaning of logical expressions. But it's not just giving me an AI summary, it's also giving me academic references that I can use to back this up and that I can go and read through to develop my understanding. So that's given me a really good base that I can use to go and do further research. The Consensus search engine, it's free to use. There is a pro option, and we've partnered with Consensus to give you guys 1 year of Consensus Premium absolutely free using the code ATTICPhilosophy1. Take a look down in the description. So within philosophy, philosophical theories of meaning, this Wittgensteinian take was adopted by Michael Dummett, one of the big intuitionist logicians, anti-realist philosophers of the 20th century. So following Wittgenstein, Dummett is arguing that meaning is not given by truth conditions, but by how we use proofs, how we construct proofs to justify statements. One of his big philosophical ideas is that truth can't be independent of how we would recognize that truth. And the way that we recognize the truth of things in logic is by giving proofs. So it's not so much that Dummett is throwing away the notion of truth and arguing for a different notion. Rather, he's replacing the traditional notion of truth as correspondence with the world with a more verificationist notion of truth. Okay, what it is for something to be true, according to Dummett, is for us to be able to verify it. And in the case of logic and maths, verifying something means giving a proof of it. So these are some of the philosophical influences for proof-theoretic semantics. There are also more technical, mathematical background figures. So in particular, you've got Gerhard Gentzen, who back in the 30s developed several different proof techniques. You've got natural deduction proofs and you've got the sequent calculus. They both come from Gentzen. So here, unlike in axiomatic systems like you get in Frege or Hilbert, what we've got in a Gentzen-style natural deduction system is rules that specify how to introduce and eliminate various symbols from a proof. And the idea is that those rules are really specifying what those symbols mean. So for instance, the rule for conjunction says, if I've got A and B, then I can infer to A, I can infer to B, and if I've got both A, B, then I can infer to A and B. That's the introduction rule. And really, once I've got the hang of those rules, that is all there is to know about the meaning of and. Just that the two things together, I can combine them into A and B, and once I've got A and B, I can get A, B from it. That really exhausts the meaning of that symbol. So the proof rules, in kind of a natural deduction style, that is what gives the meaning of that particular symbol. So on the technical side of things, the natural deduction proof style was developed by a bunch of people throughout the 20th century, notably by Dag Pravits. He looked at some normalization techniques. There the idea is we can always give proofs without going via any detours. We can just give the kind of direct proof. So Pravits' idea is that it's going to be these normal proofs specifically that account for the meanings of the terms involved. And taking this even further, you've got people like Per Martin Löf, the Swedish logician, who develops a whole constructive type theory around these notions of proof-theoretic meaning. And this is kind of a really important contemporary movement in computer science and proof theory, where we're looking at proofs not just as ways of proving things in logic, but really connecting up with programs and computability. And this kind of technical work is kind of summed up in the idea of the Curry-Howard correspondence. So this is the idea that there is this deep connection between logic and computation and type theory, okay? So what does that mean exactly? So there is this slogan that you get in this area of research. A proof is a program and a formula is a type. Or a proposition is a type, kind of meaning the same thing. So this is a really deep idea. I'm going to go into it in more detail in a future video. But the rough idea is this. A proof isn't just something that gives us knowledge that something is true. Rather, a proof is an object in its own right, that it's got this kind of structure that allows us to run it like a program. okay, like a computer program. So there is this deep link between logic and the notion of computability, of running a proof in a computer. And within this area of computer science, the idea is that it is the execution or the possible execution of these kind of programs that gives these formulas their meaning. So let's think about some of the questions that come up when we're talking about proof-theoretic semantics. So when we're talking about giving the meaning of the logical symbols in terms of proof rules or computer programs for constructing these kind of things. So one question that comes up is this approach committed to intuitionistic logic? Is it committed to a non-classical way of understanding meaning and the world? So the key feature of intuitionistic or constructive logic, as opposed to classical logic, is that intuitionistic logic doesn't accept the law of excluded middle, P or not P. Or maybe a slightly different way of putting it, every sentence is either true or false. Okay? If we are thinking about things in terms of proofs, well, I might not be able to prove P, I might not be able to disprove P, that means I might not be able to prove not P, so in that case I wouldn't be able to assert P or not P. In classical logic, I get to assert that for free, but not in intuitionistic logic. So historically, like we've already talked about, there is this kind of strong correlation between intuitionistic or constructive logic, constructive mathematics, and proof-theoretic accounts of meaning. So, for instance, Gentzen, who developed natural deduction and sequent calculus, he was influenced by Brouwer, who was the kind of developer of intuitionistic logic. Michael Dummett was a big anti-realist and intuitionistic logician. Pravitz was interested in intuitionistic logic, intuitionistic natural deduction. And finally, Martin Loth, his type theory, well, it's heavily constructive, meaning anti-realist or intuitionistic. Lots of contemporary approaches along these lines are based in ideas in computer science where we're thinking about meaning as being tied to, can my computer run this thing? Okay, so it's not the truth of the matter that's really of interest here. It's ideas of, can we construct these things? Could a computer potentially construct these meanings? And that is an idea that very naturally fits in with intuitionistic logic. So there are some fairly deep reasons for thinking that proof-theoretic approaches are committed to intuitionistic logic. So one is just the kind of format of proofs that are often used in proof-theoretic semantics. So natural deduction or sequent calculus. Natural deduction in particular just looks a lot nicer for intuitionistic logic as opposed to classical logic. If we take a nice natural deduction system for intuitionistic logic, we have these lovely rules, an introduction and an elimination rule for each constant. To get it to work for classical logic, we have to kind of add some slightly ugly stuff to get it to work properly. And I mentioned before Pravitz's idea of normalization. So we give normal proofs where there's no detour in the proof. That works really nicely for intuitionistic logic, intuitionistic natural deduction. We can always give a proof that's a normal proof. Classical logic, it's a little bit more tricky. Okay, so maybe this isn't a super strong reason for going for intuitionistic logic if you're a proof-theoretic kind of person, but it's some motivation. A different way of assessing the debate whether proof-theoretic semantics is committed to a constructive or intuitionistic logic is to look at the sequent calculus, okay? So in the sequent calculus, we're manipulating statements, sequence that look like this. Now, here's an interesting fact. If we formulate a natural system with rules based around sequence like this, it comes out intuitionistic. But if we allow multiple sentences over on the right-hand side, a multiple conclusion system, then our intuitionistic sequent calculus magically transforms into a classical logic sequent calculus. Okay, so we can give a proof-theoretic semantics for classical logic. And then there's a whole debate about whether multiple conclusion proof systems make sense, right? Lots of people argue that they don't, because when I give you an argument, I might have lots of premises, but there should be one conclusion, not multiple conclusions. So there's this asymmetry between premises coming before and conclusions coming after. Maybe many premises, but there should just be one conclusion. But other people have argued, no, it makes perfect sense to have multiple conclusions. For instance, if I've got a whole bunch of sentences in my premises and a whole bunch of sentences in my conclusions, then one way of understanding that, and this is due to Greg Restall, is to say something like, well, it would be irrational to accept all the premises while denying all of the conclusions. So I think the jury is out here on whether multiple conclusion sequence systems make sense. I mean, personally, I think they do. And also on whether they would provide a good proof-theoretic semantics for classical logic. Probably the deepest reason for thinking that proof-theoretic semantics goes with intuitionistic constructive logic is the one I mentioned earlier. The idea that if we're going to understand truth in terms of provability, then excluded middle, P or not P, looks in trouble. Because I might not be able to prove P, I might not be able to prove not P. There's plenty of cases like that, in which case I'm not in a position to assert P or not P. So I can't adopt classical logic. So if I'm understanding truth in terms of proof, like you would do on a proof-theoretic semantics, that seems to be a fairly good reason for adopting intuitionistic or constructive logic, rejecting the law of excluded middle. Okay, let's talk about some philosophical problems for proof-theoretic semantics. The first problem is the Tonk problem. This is due to the logician Arthur Prior. So if we're saying that the meaning of a symbol is given by specifying some proof rules for it, then what is to stop me coming up with a new word or a new symbol and trying to give it a meaning with whatever proof rules I like? So here's a new word, Tonk. Here are some proof rules for Tonk. They look pretty good. Apart from using these rules, I can prove literally any sentence I like, okay? That should make this concept completely meaningless because it will just trivialize any proof system. So somebody who adopts a truth-theoretic approach to meaning has a really nice approach here because they say there is no proper truth function that I can associate with Tonk. It's just going to trivialize the system by making everything true kind of straight away. But if you think that proof rules are sufficient for giving meaning, well, I've given some proof rules, so why doesn't this thing have a meaning? That's quite a tricky question for proof-theoretic semantics to answer. And there are a whole bunch of answers out there from Dummett, from Tennant. The idea is the proof rules have to be of the right kind. But as always with these philosophical debates, it's kind of tricky to specify exactly what that requirement should look like. So this isn't a complete knockdown objection, but I think the jury is out on whether proof-theoretic semantics can put the right kind of restrictions on proof rules to avoid this kind of problem. A second kind of issue is the knowability problem. Okay, so this is sometimes called the Fitch paradox or the Church-Fitch paradox. So this is a problem for the principle that all truths are knowable in principle. And the problem is that we can give a little bit of reasoning that shows that if we assume that all truths are knowable, we can derive from that all truths are in fact known. Okay, but that kind of seems absurd. There are truths out there in the world that nobody knows. So not all truths are known, so it looks like not all truths are knowable. Okay, why is that a problem for proof-theoretic semantics? Well, part of the idea of a proof is that it's something that in principle we could carry out. Now maybe we haven't got enough time or paper, but in principle, we could write down all the steps of that proof to come to know the answer. So provable sentences are ones that are, in principle, discoverable, knowable. Okay, so proof-theoretic semantics, for something to be meaningful, it has to be knowable on this view. So it does seem committed to the principle that all truths are knowable. Okay, that seems to be a commitment of proof-theoretic semantics, but that's going to have the absurd implication that all truths are in fact known. Now, just to be clear, not everyone agrees with this kind of reasoning, but personally, I find this a pretty deep problem for proof-theoretic semantics and for anti-realist approaches to meaning in general. It's really one of the main reasons that pushes me towards realist and classical logic understandings of reality. Okay, so here's a question for you guys. What do you think constitutes meaning and logic? Is it to do with truth or is it to do with proof? Let me know down in the comments. And if you've got any questions you'd like to ask about this material or anything else to do with philosophy or logic, leave me a question down below. If you have got something out of watching this content, you can do me a favour, hit that thumbs up button, subscribe to the channel, and if you want to, you can buy me a coffee over on Ko-Fi. Thank you so much for watching this far. I really appreciate it. Thanks to Consensus. Thanks to all my Ko-Fi supporters for making this content possible. I really appreciate it, and I hope to see you guys back on Attic Philosophy soon.